Okay, hey y'all. This is our last recorded video. You'll have this lesson today, and then you'll have another one that's like this, same topic, just more practice. Then you'll have a quiz over radical equations, and that's it. The last week, you'll take that quiz on Monday, and then I have to sneeze. Excuse me. And then the last couple days, I'm just going to give you some concept just to review some of our major topics, some of the factoring and whatnot, to help you get ready for next year. And that's it. So you guys have rocked this. You've done great. I am so proud of you. Okay, so we've been talking about radicals and simplifying radicals, all of those things. So what we're going to talk about today is radical equations and how to solve those. So our step 1 says isolate the radical on one side of the equation if you can. Then it says raise each side of the equation to the power of the index to eliminate the radical sign. Solve the remaining equation and then check for extraneous solutions. This is important because there are going to be some of them that do not work. And if it does not check, then the answer is going to be no solution. Okay, these first ones are very basic. We're going to isolate by subtracting 5. The square root of x equals 12 minus 5, which is what? 7? Yeah. Then we're going to take the square root, not the square root, I'm sorry. We're going to take the square of both sides. So x equals 49, which is super easy, but we need to do a check every time. The square root of 49 plus 5 equals 12. So that's going to be 7 plus 5, and that does equal 12. So that checks. This is my answer. Okay? Next one. Subtract 3. Negative 4th root of m equals negative 3. That's fine. I'm going to get rid of that negative by dividing both sides by negative 1. 4th root of m equals positive 3. To get rid of that 4th root, I'm going to take and raise both sides to the 4th power. Okay, so the 4th power and the 4th root cancel each other out. So m equals 3 to the 4th power, which is 81. Now, before I box that and say that's my answer, what I'm going to do is I'm going to check it. 3 minus the 4th root of 81 equals 0. 3 minus the 4th root of 81 is 3. So 3 minus 3 does equal 0, so it checks. Okay, I'm going to pop over and show you the key. I'm going to do that several times throughout this. If you look at 3, they subtract 10, 1. Take this, our square both sides. That gets rid of the radical. 1 squared is just 1. Subtract 7. That gives you negative 6. Over here, we're doing our check. We plug in negative 6. You do what's under the radical first, so that gives us 1. The square root of 1 is 1. 10 plus 1 is 11, so that checks. If we look at number 4, okay, first thing we have to do is subtract 10. That gives us negative 7. You square both sides. That's 49. Get rid of the radical. Add 5, 54. Divide by 6 gives us 9. Now she's got a slash through it. The reason is when you come over here and check it, you get 54 minus 5, which is 49. Square root of 49 is 7. 7 plus 10 is not 3. So because that did not work out, that one has no solution. Okay, back to me. Let's look at number 5. Now, the reason I want to show you number 5 is because this exponent is taking place of our radical, because remember the denominator is going to be your index number. So this is actually the square root. So before I can do anything, I need to get rid of that negative 9 because that's square root. This only applies to what's inside the parentheses. So I'm going to divide both sides by negative 9. Dividing by negative 9 is going to give me 4 on this side. Now, all I'm going to do is raise this to the second power. Okay, so I'm basically taking this and saying, okay, well, I'm going to raise the entire thing to the second power because 2 times 1 is 2, 1. So it gets rid of that, and you no longer have that. So exactly what we're doing in these examples. It just doesn't have it written as 1/2. It actually has the square root. Well, the square root and square cancel each other out. That's the same thing down here. And again, you do it to both sides. So that gives me 16. I just canceled out the 1/2. So C minus 12 equals 16. I add 12 to both sides. So C equals 28. Again, I have to check. So, negative 36 equals negative 9 in parentheses, 28 minus 12 to the 1/2 power. Now, if you've got your fancy calculators, then you can just check those easy, easy by plugging them in. Okay, so all I'm going to do is put negative 9 parentheses, 28 minus 12, and I'm going to raise that to the 1/2 power, which does give me negative 36. So that does work. Now, you don't have to do that all in your calculator. You could have just done 28 minus 12. That's 16. The square root of 16 is 4. 4 times negative 9 gives you negative 36. So you're going to get the answer even if you do it in multiple steps, if your calculator won't allow you to type all that in together. Okay, let's flip over and look at number 6. That's us. There's number 6 down here. Let me zoom in. Okay, so on number 6, you can see we got to get rid of that 11 first. You subtract that, it gives you negative 4. To get rid of the 1/3, you raise it to the 3rd power on both sides. That cancels that out, leaves you with 7p minus 1 equals negative 64. Add 1, negative 63, divide by 7, that gives you negative 9. You have to come back in here, perform the check. You can see that she did her steps all right here together. 7 times negative 9 is negative 63, minus 1 is negative 64. To the 3rd power is really, or to the 1/3 power is taking the cubed root of that, which is negative 4, plus 11 gives you 7. So that checks. If we look at number 8, they add 9. They're going to raise both sides to the 4th power. Then they are going to subtract 12, divide by 8. Their answer is 1/2. When you plug it back in, it does not check. Over here, we're going to subtract 18 first. Then we are going to divide by negative 4. Then we are going to square both sides to get rid of that radical. After that, we're going to subtract 43. Divide by negative 3. Your answer is 6. You plug it back in, and it checks. Just that easy. To me. Okay. Now, if you look at number 9, number 9 has a radical on both sides. So since it has a radical on both sides, what we need to do is we need to get rid of that radical. So I'm going to square both sides, because whatever you do to one side, you have to do to the other. And in this case, it's going to cancel out both of those radicals. And so now you're just back in Algebra 1. You got to get your like terms together. So I'm going to subtract u. I'm going to subtract 43. So my u's cancel, my 43's cancel. Over here, I've got negative 51 equals over here negative 3u. Divide by negative 3 on both sides. So u equals, that's, I don't know what that is. That is 17. Positive 17. So then you do a check. With your check, you have to plug in that 17 to both sides, you guys. So you're taking that 43 minus 2 times 17. Then you have to work out each side. So 17 minus 8 is 9. The square root of 9 is 3. Over here, we've got 2 times 17, and then 43 minus that is also going to be the square root of 9, which is 3. So it checks on both sides, which means that is fine. Let's go look at our key for number 9. Okay, if we look at number 9, you can see exactly what I just saw. Number 10 over here, this is the 4th root on each side, so we raise it to the 4th power. Again, it cancels. Get your like terms together. That gives you 10. Plug it in, do your check. Now, 7, if you simplify what's underneath the radical, you get 7. Well, 7's not a perfect 4th root, but you get the same thing underneath the radical on this side as you do the right side, so you're good to say that that is fine, okay? Over here, now 11. If you look at number 11, they do have a radical on both sides. This one has 4 on the outside and this one has 12. So we can simplify both sides by dividing by 4. Dividing this side by 4 cancels out that 4 completely. Dividing this side by 4 is going to simplify it to be 3. So we can't get this side, the right side, by itself completely, but at least we can simplify it. Then we're going to square both sides because our index is 2. That completely gets rid of that radical and leaves you with 3q plus 15. Over here, you have to square 3 as well as get rid of the radical. So 3 squared is 9, and then you drop the radical, which means we have 9q. Subtract 3q, that gives you 6q. Divide by 6, then simplify your fraction. Simply plug your fraction in, perform your check, you're good to go. Over here, same thing. This has -2 up front, no big deal. We're going to raise each side to the 3rd power because our index is 3. Don't forget to raise that -2 to the 3rd power to get -8. Drops the radical, so we just have n. Then you solve it out. Do your check. Number 13, if we look at 13, I'm going to square this side to get rid of that radical, which means I also have to square this side. Well, that's going to give us an x squared, so we're dealing with a quadratic. If you are solving a quadratic, you guys, you can either do factoring, you can also do the quadratic formula, any of those. So this is getting into like a more of an upper level algebra 2. So I'm setting it equal to 0. Then you can see that this one doesn't have the c. We've got ax squared plus bx, but no c. So what they did is they did the greatest common factor. She took out her greatest common factor, which is x, and then this one is x minus 8. That's what would be left over. It's like undistributing. And so then she just set each one equal to 0 on its own. So x equals 0 is one of our solutions. If you set this one equal to 0, it's going to be positive 8. So you have 2 solutions because it's quadratic, because you have a x squared. Then you need to check both. So you plug them in. That one checks. Plug this one in. That one checks. So you're good to go. Okay, over here, I am going to isolate my radical by subtracting 7a. That leaves me with a single a. Square both sides to get rid of the square root. Gets rid of that square root, but then it leaves this side squared. So again, I need to set it equal to 0. Sorry. Now, you'll see that we did not subtract this way. We don't have a negative a squared. You do not want your leading coefficient, your a squared, to be negative. So they added a, that's why we have a positive a, and subtract 12. That's why we have a negative 12. This one is factorable. The factors of negative 12 that give you positive 1 are 4 and 3. So she factored it out. Set each one equal to 0. This is negative 4. This is positive 3. She did her checks. Easy, easy. Okay, for this one, square, square. Now, you remember that if you have a binomial squared, you have to do FOIL. Okay, so she just has her answer here, but the only way to get this is to actually do FOIL. Okay, then you're going to set it equal to 0 by subtracting 3, adding 38, and this is your polynomial, your quadratic. Again, she factored the factors of 63 that give her a sum of negative 16 is negative 7 and negative 9. set them equal to 0, get your answers, do your checks. Over here, same thing. You have to square this over here, which means we are going to have to do FOIL, okay, or the area model. If you're one of the ones that does the box, you would be doing your 2x2 pundit square box right here to get this. Subtract your 2v, subtract your 3. This is going to be my polynomial. Again, it's factorable. If you guys don't want to factor, you can always use the quadratic formula, and that will work. The factors of 1 that give you positive 2 are 1 and 1. So there's that. Check it. Ta-da. Here we are. Again, you have to take that. You need to do FOIL. Subtract 51, add 5y. Here's your polynomial. Your factors are -10 and -7. Set them equal to 0, but neither of your checks work, so this one has no solution. Over here, this one's a little bit tricky, you guys. When you do 18, you do have to do FOIL with this one. Let me work 18 out for you. Okay, if we look at 18, we're going to square both sides like we've been doing each time to get rid of those radicals there. So that's just totally going to drop and be gone. Now, I've been saying this to you, but I haven't actually done it, so I'm going to show this to you. You have to do FOIL. Do not forget that on the ACT. You cannot just distribute that too. So that means I have the square root of x times the square root of x, so that would be the square root of x squared, which means it's just going to cancel out, so that would just be x. Then we have the square root of x times -1, so that's going to be the negative square root of x. -1 times the square root of x is again negative square root of x. -1 times -1 would be positive 1, because a negative times a negative is a positive. These are our like terms. This is like 1 and 1, so that would be -2 square root of x plus 1. That's x. Just like that. Make sure I did that right. Yes. Okay. So then I'm going to bring this x over and join it with the other x, which you can see cancels out, cancels out. I'm going to subtract my 9. Okay, that cancels out. So 0 equals -2 square root of x minus 8. And actually that was dumb. I should not have done it that way, but whatever, I already did it. So now I'm going to add 8. So 8 equals -2 square root of x. Divide by -2. So that gives me -4 equals the square root of x. So here we are again, trying to get rid of that radical. So I'm going to square both sides. So x equals positive 16. Well, then you have to do your check. Okay, so we do our check by plugging it in. The square root of 16 plus 9, and then the square root of 16, and then plus 1 is not underneath that radical. Can y'all see that? No. Here I am doing my check. 16 plus 9 is 25. The square root of 25 is 5. So that's great. The square root of 16 is 4. 4 plus 1 is 5. Did I write this down? Oh, okay, because I was like, she said no solution. This is supposed to be minus. So 4 minus 1 is 3. So that is not going to work, so no solution. Okay, I did that as fast as I could. I know that was really fast, but this is solving radical equations. You have this key. Let me come back to this key. If you need to take a picture of this so you have the key to your notes to help you out, you're more than welcome to. Remember that with the quadratic ones, you have to either do FOIL or the quadratic formula. Y'all let me know if you need any help, and I love you, and I hate that I won't get to see you via video anymore, but let me know if you have any questions on your mind.